So yeah, welcome everyone again. So my name's Fred Hirsch, and I am product lead for Open Health Stack and with Google Health, and we've been involved with the community here organizing this Open Digital Health Summit. And we're going to kick off the next couple of hours. We're really going to go into some of the kind of concepts around building with fire. We have a kind of a Q&A kind of platform that you can use there. So again, once you're finished doing your registration, you're registering your preferences, please just grab that. Over the next couple of, between now and lunch, we'll just run through the sessions, kind of almost like a series of just lightning talks, okay? You're gonna hear from a bunch of different people, range of different topics, and then we'll try to make sure that we have 10, 15 minutes at least for lunch. This is also very useful if you're kind of if you're new to FHIR, you're learning, you have some burning questions, literally, please drop them in there so they don't have to relate necessarily to the presentations that you've seen. We have Graham Grieve and Diego Camina from the HL7 FHIR team. They'll be joining us tomorrow. And so that we'll share with them if there are specific topics that you'd really like to spend a little bit more time on, just leave them in there and we'll make sure to pass that on, okay? Great. So just to start off, just out of interest, so who here is already working with FHIR, building on FHIR in some capacity? Okay, about half the room. And just out of interest, and entertain me please, who has heard of Open Health Stack? Okay, cool, great. All right. So, like many of you, we at Google and Google Health have really been, looking at this problem of how do we address a lot of the health disparities, health equity and access issues, right? That really, I think, drives most of us. And we believe, like you, that digital health and particularly, future AI opportunities really can be a vector for trying to address this kind of quality healthcare for all at scale. But we know that there are a number of different challenges, and these are just some of them, okay? And so we hear a lot about open standards today. I mean, historically, we haven't really had at least an open standard to be able to build to, particularly for digital health solutions. And we've kind of had program-centric approaches and other things that have really led to fragmentation of data and silos. We know that evidence-based guidelines often get lost in translation, and this contributes to poor quality care. And we also think that there are elements of design and usability that if we can address those, that can also improve the experience of using applications, and that also contributes to challenges to scale. And so for all of the talk about interoperability, which we know has been a feature of the ecosystem, if you like, for a long time, today it's still very difficult. I mean, it is possible. We know that it is possible, but it's challenging, it's expensive, right, to get to interoperable digital health solutions. And as I mentioned, interoperability has been a feature. This is not the first time that we're talking about it. Many of you are probably very well versed in all of these, but we've had various principles and strategies from the community. We had the great digital and health report from the World Bank last year that really kind of highlighted and emphasized that there have been significant investments in digital health, and it's like, how do we kind of really start to stitch these together now to deliver on that promise of it? And then the full stack remedy for digital global health that Garrett mentioned. This is talking about this convergence of these factors, this open standards, open technologies, architectures, and content, that perhaps this is really the opportunity for us to transition and achieve that digital, person-centric digital transformation for health. And what we're really talking about in this session falls under that open technologies piece, right? So these are open source, digital public goods, technologies that are like the building blocks that help to bring things together. You heard from Carl and Jing about FHIR. Not going to go into it in too much detail, but just a quick reminder, it's an open specification for data exchange. But what's really appealing about it is that it also brings these APIs. That means that web developers, digital health developers, can kind of get involved and learn it, pick it up quickly. And it's got an extensible data model, as Jing talked about the 80-20 rule and profiling and implementation guides, and we'll hear a little bit about that. And so it's really about driving towards that syntactic and semantic interoperability But despite being easy maybe to get started with, I think for those of us in the room that know it can be challenging to adopt new standards, right? There's always a lift, there's certainly a learning curve, and that's certainly what we've seen in our work. And so when we kind of started to approach this problem, we were thinking, well, how can we reduce the technical complexity, right, of working with standards so that people everywhere, developers everywhere, can be using them in their solutions. And so today, this is obviously a gross simplification, but I think there's a lot of time spent, building and maintaining kind of complete stacks, if you like. There's a lot of energy that's keeping that iceberg, kind of going underneath the surface. And like, what if, there was some more enabling infrastructure that would make it easier to build standards, so it would solve some of the practical problems that developers face, but make it easier to work with the standards, promote interoperability. As we heard, it's not the silver bullet, but it's going to promote interoperability and enable more local innovation. And I think that's really also a very essential component. So if we're spending less time, do we have a pointer? No, with the things under the surface, does that free up the valuable and very finite resources that can be spent on solving those local problems? And that's really where Open Health Stack fits in. So the mission of our team is around helping and to accelerate the development of these next-gen solutions that can enable better quality to better higher quality in the future AI-powered healthcare. And I just want to emphasize, helping. This is a community, right? There is a common thread towards driving towards digital transformation for health, and we see our role in trying to help catalyze that a little bit, accelerate it a bit. But it's really, I think, through the efforts of many people in this room that we're really here today. And so when we think about next gen, we think about person-centric. So these are promoting the use of interoperable standards so that data can follow patients. We think about data-driven. So how do we use data either at the point of care, and so that's like, for example, the WHO SMART guidelines. How do we bring those evidence-based decision-making into the hands of frontline health workers? But also, how are we thinking about data use through analytics? How are we getting real-time or near real-time access to insights that can drive decision-making and create, if you like, a marketplace for innovation? So I suppose one of the hopes here is back to that innovation story, which is that if we can kind of make it easier to do the common things that are commonly done, does that unlock opportunities for developers moving up the value chain, if you like, thinking more about what are they adding in terms of the specific solutions and others, as well as bringing in AI and future capabilities there. So about 18 months ago now, so I think back in March of last year, we launched Open Health Stack. And Open Health Stack is a suite of open source components that helps developers to build these next-gen digital health solutions. And there are 3 components, and we'll hear a little bit about each of these. But it's really about, on the one hand, on the Android Fire SDK side, it's about building faster on Android, enabling, Fire native, offline capable, mobile apps. And then on the server side, it's like, how do we help to enforce access controls, making sure that solutions, preserve privacy, and then unlocking insights. So making it easier to work with Fire data, and we'll touch this a little bit. And just important to point out that, we are talking about Fire, and Fire is used all around the world. But some of the components, I suppose, some of the problems that we're trying to solve here specifically relate to the context of building in low resource environments, right? Offline capabilities, maybe there isn't cloud capabilities, so how do we deploy into local data centers and that type of thing? So you're going to hear about this more in some of the other talks and if you do some of the Let's Build sessions, but just very quickly, the Android Fire SDK is really, these are building blocks, a set of libraries that you can bake into your Android application that makes it easier to leverage the benefits of Fire. Has a set of APIs that you can sync data from a Fire server. You can then manage that data locally. You can do on-device searching. One way to think about it is also like the ODK, if you like, for Fire. I think most people here are familiar with Open Data Kit or some of those types of technologies. And so this structured data capture library, which you'll hear more about in a minute, is really like that. It's kind of taking the FHIR questionnaires and the SDC specification and allowing you to very quickly generate data management tools. It also has some fancy features around being able to deploy FHIR implementation guides and run pretty complex operations. So there's actually the ability to run CQL, and these are essential for being able to bring those smart guidelines, those computable decision support to life in applications. Then we have the FHIR Info Gateway, and the FHIR Info Gateway is really trying to solve a pretty important, but maybe often kind of a hidden problem, right? Which is how do we really ensure that the right people have access to the data that they should have when we're building solutions, right? And there are ways that you can do this with the tools that exist today, but often there's a lot of repeatable. People are building the same types of things, or they're in commercial packages. So this is designed specifically to be a standalone reverse proxy that basically allows you to speak to any kind of FHIR backend and helps you in a pluggable, kind of customizable way define how you want to enforce those access control policies that are set at the organizational level. It also helps to kind of bring some of the smart on FHIR capabilities of the specification to life simply and easily. And when you link it together with an application built on the Android FHIR SDK, it can also help with some of those sync operations. And we'll hear more a bit about that. And then lastly, we know how people are familiar, but FHIR is a great, nested structure for representing, the richness of that patient interaction and all the information that we might want to be capturing throughout an encounter. But that same kind of makes it very challenging to do analytics, particularly when we want to use SQL tools and things like this, right? So a FHIR analytics is a set of pipelines that transforms data, horizontally scalable, as well as a view generation layer that allows you to then, run this on different types of data warehouses. So whether that's a Postgres kind of setup, or you want to use the rich data within Parquet and use that for data science or machine learning or other kind of operations. And we've also been very involved with some of the emerging standards around SQL on FHIR v2. And you'll hear more of this from Patrick, and also in the hands-on session, if you do that one on analytics with Bashir later today. Okay. So the point of this slide is just to remind us that these components are built to solve individual problems, and they can be used individually, right? It's not a platform, it's a stack of components that can be used together. But when used together, they can also kind of quite nicely form the backbone of a new digital health solution, right? So whether it's a new system or you're trying to integrate with existing systems, we're trying to maybe close some of the gaps that we see, but it's certainly not the whole ecosystem, right? And it's important to point that out. And all the things in the blue are the solutions, the new platforms that are built by the developers, by the system integrators, by you. And so I just wanted to highlight that it's really important that we think about, it's not just about FHIR versus non-FHIR or this. We know there's a lot of amazing work that has happened, is happening, and will continue to happen. And it's kind of like, how do we think about, this kind of best of both worlds? How do we maybe start to unlock some of the opportunities with FHIR-based systems or using FHIR in different ways? And so these are just some kind of patterns, if you like, that we've started to map out with existing global goods. And I'm sure there are others out there, and these are more just to kind of explain, I suppose, how the community is thinking about this at the moment. So for example, I might want to bring in a FHIR server, and I'm going to maybe build a new FHIR app, but I want to make sure that it can integrate with or interoperate with my non-FHIR based app. And we know there's a lot of work that goes into different kind of mapping or data transformation tools, and we're going to have a detailed session or a lightning talk session on that. But what about if I have an existing like OpenMRS system or some other system? Well, if it's got a FHIR API that's exposed because it has a FHIR facade that's been implemented, like OpenMRS does, now I can think about how could I connect that up with an app that's built on the Android Fire SDK, for example. And there's some work that's going on to do exactly this at the moment. And then I can use, because I'm using Fire, and there's a Fire API, I have a Fire facade, I can actually, my Fire data pipes can take the data from that. And the Fire analytics work, the data pipes is the component within that, actually originated out of this OpenMRS Fire analytics work. And then similarly, there are existing HMISs, of course DHIS 2, and others that have their own APIs. And there are ways, of connecting directly through Fire adapters, so either from the Fire server into that. But similarly, you can go through your analytics, use that data to be able to effectively build dashboards at the local level and other things, but still very effectively land those aggregates, into the reporting systems that countries want to have. Okay. So beyond the technical components, we're also providing a lot of developer resources, there's design guidelines, and working more on some of the advanced integrations, which we won't cover today. And I just wanted to highlight a couple of things. We've just pushed a new update to our developer site where we've really been focusing on how do we bring tools and tutorials and more developer resources to make it easier to build with OHS, right? So you can go to the dev site, it's ohs.dev. You'll see, some of these video tutorials. That's the playlist. I just wanted to embarrass everybody at the same time, not just myself. But we're making videos to make it easier to get started with these things that are often tagged to code labs and others. And as you heard, this work is really part of a collaboration with the WHO that's been going on for the last few years. And as I mentioned, part of that full stack approach, but really about bringing some of the SMART guidelines, which you'll learn more about on day 3 under our kind of open content piece, helping to like realize that through mobile-based tools and solutions. And as I've mentioned, I think many times, it's a vast and diverse partner ecosystem, right? So it's been great. We've got a lot of technical partners that are building with this, and increasingly other organizations that are really kind of excited and supportive of that, as well as working with some of the standard settings bodies like Fire. And this is not an exhaustive list. And for us, what's been amazing to start to see is the solution. So, we have technical partners that are at different stages of leveraging different components of Open Health Stack into their solutions, and starting to see some of these actually get out into the field and see the real impact that they're having has been very rewarding. And again, on the developer side there, we try to publish some of these case studies on a regular basis where we can. And I wanted to really highlight that a big shout out to a number of, we've put this up as well as part of our developer site, but really to recognize the contributions that are coming from the community of developers that are engaged and working with Open Health Stack. So this is just, I suppose, the first part. There's a number of we call them code heroes that have really been contributing to the code, and we really want to see more of that. And we're going to talk more about like how people can get involved, and we'd love you to get involved. So how can you get involved? So the best place to start is really to go to the developer site. As I said, you should be able to navigate to the community section that we've just launched as part of this. There will be opportunities to contribute at each of the different GitHub repositories, so depending on where you are. We're launching some new forums that we hope will be a good place where we can start to have some conversations around this. So if you have ideas, feature requests, you're having difficulties, that's the place to start to go, and the community will be able to provide some support. We run weekly developer calls, so these alternate between the mobile side and the server side. You just have to email us at that OHS Developers External, and we'll add you to the developer group. And if you are someone that has been working with OHS or interested to run a workshop, we've also started to put together a lot of the training materials, some of which many of you will go through today, that you could then run to be the local leads and the local experts helping others to really start to build with Fire. Great. And this is, if you didn't catch the developer site already, you can just scan that QR code. All right. Thank you very much. All right. So now we're going to kick off a bunch of lightning talks. We've got 5 talks. We're going to try to stick to 15 minutes and have a little bit of time for questions. So there is a timekeeper in the back. You'll get a 5-minute warning and a 1-minute warning. So again, if you didn't catch that, if you want to drop questions, drop them there, and then we'll try to have some time for Q&A at the end. Terrific. All right. I'd like to invite Jose, who's going to give us a talk on authoring FHIR artifacts.
Yes, please. Thank you, Fred. Yeah, hi everyone. I'm Jose. I'm before we go into the content, I'm sorry for my bad voice. Recovering from something. I'm working with FHIR for a while, actually 10 years now. I'm a contributor to FHIR. I'm been exploring FHIR from the tooling and from the community side. I'm originally from Portugal, and I come from, but I'm living in Belgium, where I actually helped set up the national standardization program. So FHIR was a very good excuse for us to start doing healthcare right. And I guess some of you will have the same opportunity in your countries to use FHIR as an excuse to do something better, to do more open specifications, to do iterative, to use APIs instead of boring flat file exchanges. So we are here to discuss a couple of technical things. I'm not going to the technical weeds, but I'm going to share some of the aspects as technical people, the things that after some experience you will encounter. So I hope to share some of the experience. The technical part is easy, as you know. But before that, I would like to have a, where's the clicking thing? The bottom one. Up, yeah. So who are we? I would like to have a very quick impression of the room. If you are one of those people that are looking at FHIR and stuff, and the first question that comes to mind is, where's the source? Please raise your hand. Like technical people, so if you want to see how these things technically happen. I'm guessing most of you are in that field. No one yet? Okay, the other extreme is the people that like, what are those tech guys doing? That's management people. Anyone here? Thank you. So the rest is in between, I guess. We are going to talk to those, to both those groups today. So it's a very short introduction to several topics. But we had this framework, so one of the things while planning FHIR trainings or standards trainings for different people, we realized that we had to structure information. This is just a map that we made for the kind of knowledge that we are talking about. So this is just to see where we are. And I would like everyone to see where they are in the standardization process or in the authoring process. This is just for us to see, am I more on the technical side? Am I more on the governance side? What are the things that matter to us? There is plenty for everyone if you start doing FHIR. I just want to see that those are different groups, different audiences with different concerns. So authoring FHIR is a very technical thing. We are going to mention the technical aspects of FHIR, but it should be made accessible. My talk today is about how are we making these things more accessible to non-technical people and being steered by a workable process. So what is FHIR? FHIR is, we've heard most of it today. FHIR is a data exchange standard managed by HL7, which is an organization called Health Level 7. Has a set of resources, and it integrates the industry best practices. Not only the JSON and the REST, the use of JSON and REST APIs, but also structured and interoperable terminology. So FHIR has a very good connection with terminologies. The data exchange for FHIR is also based on some maturity that has been learned over the years by the community. And it brings out of the box key considerations about licensing and intellectual property, security, mappings. We'll see some of those today. So FHIR encapsulates, or the FHIR ecosystem encapsulates lots of things that we as technologists working in healthcare, we will encounter whether we want it or not. So it's also a set of machine readable specifications. This is really important for us techies, that once we make something machine readable, then we get rid of paper reading and manual review of lots of specifications. The computers can do lots of the work for us. And this has been one of the key success factors of FHIR. We have a lot of tools because of that. We have FHIR validators, FHIR servers. We have I heard about a prototype by the HIS2 team about clicking a button, having a logical model, and then bam, you have a compatible interface defined. I think it was using Kafka or something. So we have lots of tools because everything is machine readable. Most important is an open standard managed by a process. So there are processes for managing fire in the ecosystem, and it's a very vibrant community. It's a lot of people that are giving their best to advance healthcare. We are talking about fire profiling. What is fire profiling? Fire is the 80-20 rule. You've seen it. When we do fire profiling, we are talking about a way to contextualize and constrain fire resources. So we take those fire resources, we select which ones we want for our country, for our project, for our scope, and we say which are the parts that we like, which are the parts that we don't want to have, which are the parts that we need to add. That's when we handle the 20% of the rule. So the outcome of this is a lot of technical deliverables, really technical deliverables, so really, really technical. One of the aspects of this is that we will do lots of JSON artifacts and XML artifacts. Less is good. Reusing as much as possible is important. This is something that we techies, we tend to forget. We like to show, oh, I made an implementation guide with 500 resources. That's really good, but it makes the next person's job very difficult. It doesn't give much more information to managers and makes our own lives misery, because now we have 500 flavors of something, 500 flavors on the other side, and systems are no longer interoperable because they no longer talk the same dialect. This is one of the key things that we learned while doing fire. It's really easy to do technical stuff. It's really difficult to convince ourselves, let's not do too much. Let's not create another dialect because we can. So, and with this, there's an authoring process. So we have, of course, processes. That means rules. That means roles. Who's doing what? There is inputs and outputs and a lot of tools. I'm going to go through some of those. So what is fire raise of hands. Who has done fire profiles in the room? Who has done a fire profile? Who has seen a fire profile? Okay, that's good. So we had a webinar a while ago for food allergies. This is out there for explaining how the process kind of goes from the technical side. But basically, we take the fire resource. You remember seeing the patient in the plenary. We take the allergy resource in this case, and we say, let's create a food allergy. So it's like contextualizing one of the fire resources to a narrower scope. And this is how it works. We contextualize. We adapt things to a more specific scope than they were designed to. And basically, when we make a fire profile, we create a profile. So it's a technical artifact that says, this is my flavor of the allergy, or the allergy intolerance resource, and here's the terminologies that come with it. So there is some technical work to be done there. Basically, we take the global layer, and in one of our levels, we make the adaptations that we need. How it's technically authored, remind me again, who has authored fire specifications? Not so many. Who wants to author fire specifications? A few more, okay. Not that many, that's a sign of sanity, I guess. What it means to make the, so let me go back. The people that don't want to make technical specifications, who wants to manage and make sure that those specifications, or who has the task to manage and make sure those specifications come out in order? Am I missing a role here? So we are either looking at this, contributing to this, or doing this. We have clinical experts in the room. Are there clinical people that participate in the project? Okay, some as well. So the authoring is quite technical. At the end of creating a profile, what FHIR has is in case of profile, for example, is a structure definition. It's a technical artifact. It's coming from the FHIR specification itself, and we say, like in this case, if there's a pointer there, should have. We basically say that the verification status, like the first line, the bigger square there, we make it mandatory. So we say, in FHIR, this is optional, but for me, it is mandatory. That's what we do when we profile FHIR. And we say that the allergy intolerance code, we say, we don't want any code. In my project, I want to use these 14 codes. That's pretty much what it comes down to when we say FHIR profiling. We say FHIR says lots of liberty. We say, I don't need that. I need these 14 codes, and this must be mandatory. How this is authored, the two things that we are going to see here. A few years ago, when we started, there is a tool called Forge. is a really nice graphical interface where you can say, you can go to the Fire resource and say, this thing I like, this thing I want to extend, this thing I want to constrain. It was really graphic. As people developed more and more implementation guides, we realized that we needed something a bit more easy to work at scale. So Sushi came up. Sushi is a tool that parses the Fire shorthand language. Just a preview there. I'm going to go into detail of that. But that is another, so that white rectangle there is actually the source for that whole thing there. It's much more compact. So we are working on compact authoring tools. I don't know if I skipped the slide too many. Yeah. So for those that are interested in doing Fire specifications, one of the things that you will definitely encounter is the shorthand, Fire shorthand. So it's shorthand for Fire, and it allows us to make very easily all those changes. So instead of making mistakes because we forgot a comma in the JSON, or making a lot of files and seeing that actually now I cannot compare them, there's a very compact language that allows you to create those changes that I showed before. And for example, in GitHub, you can look at this and say, who changed what? So this is no longer just about how easy it is to author, but one of my concerns is how easy it is for another developer to see if I'm doing it right, for a manager to see if I missed something. These are the things that make good quality implementation guides. So shorthand is a language. It's overly specified there. If you want to see how it works, you can get there. You can go to fishschool.org, and you have lots of education and materials there. It is even expandable. You can have some macros to make the authoring even easier. So it really makes for a very compact writing of specifications. When we talk about Fire resources, so I spoke about profiles. So we create profiles, we create value sets, but we also create logical models. Logical models are definitions of data structures that help a clinician define what data we need. So clinicians should not be, in my opinion, forced to learn what is a Fire extension, what is a Fire constraint. They should know that allergy must be these 14 codes. Allergy verification status is mandatory. That's what they should be able to define. And there's a way to do that in Fire. So there is also a resource in Fire called structure definition that allows us to do these things. So we have ways for people to create this kind of content, for clinicians to say, this is why we are making this profile, because the clinicians decide that this data must be present. Another interesting resource for most of us is the questionnaires. So it's also a Fire resource, but because of the tooling that we have and because everything is machine readable, we can actually say, here's the Fire questionnaire, and the tooling will display it for us in a user-friendly form. I think this is one of the things that the Android SDK is using as well. We have lots of other resource types. The other thing that we have is mappings. So one of the challenges that we do when we author Fire specifications is how do we do mappings? So mapping to legacy systems, mapping between different profiles, because my neighboring country decided to make their own dialect, and now my boss tells me if I don't make another dialect as well, I'm not doing as much work as they are. So we make too many dialects, and we have to map things somehow. But most typically it's about legacy data or other sources of data to get this into Fire format. In authoring Fire specifications, it is a necessity. We don't have the same models. The aha there is to say, because we forgot the rule of not creating too many profiles. It's because we have our own dialects, and the more we create, the more mapping we need downstream. So we have informative mappings. We have terminology mappings, like this code in Loin corresponds to this code in SNOMED. That's some conceptual mapping. And we have the transformations for structure maps. The image there is actually a visual representation of transforming a questionnaire into a resource, the patient resource. It's just a graphical representation. Authoring this is done with a resource called the structure map. That's the thing on the right. And that thing on the right shows the scroll bar, so it's really long. So the Fire structure map is a really precise, really accurate, really thorough representation of how these things should go together. Like this field goes there. It's painful to author. So we had to come up with a representation for this. There is a structure map, which is the acronym is also very good for this language. It's also not easy to author. So we are also exploring more tools. Everything is computer readable, machine readable, so we're also exploring more things. Please read up the fire mapping language and shorthand. Those are all public specifications. Read up on this. I would wrap up with how is this all built? What is it for? So basically we have an implementation guide. You've heard about this. I think most of you have seen the implementation, some implementation guides, so I don't go into this. But the most important thing is it's a package that then feeds the tools and feeds everyone's. So if you have to send this to the sorry, I'm distracted. To the Android SDK, so there are packages. What you author comes up as a package, a technical package. You put this in implementation guide, and then the ecosystem prepares those technical packages that the tools downstream need. It's very important that you do this openly. When you author things, that's why we always go to GitHub, because if I want a colleague to debug my IG, or if I want my manager to see how things are going, always do it out there. There is a couple of considerations that come with Fire, like don't do constraints that you might want to undo in the future. And really to wrap up, for the non-technical people here, it's really important that the technical people have the right input and the good governance. Every technical author will do a great job. The problem is that two different authors will do a great job in completely different ways. So it's really important also to be aware of culture. Some cultures are more like, I will do it when I'm ready. Some cultures are more willing to say, let's do something as quickly as possible. We have to show some results. For managing this, how do you do this? Option one, let the inmates run the asylum. There's actually a book on this where software developers are pretty much running the whole process. By experience, this works well for a couple of months. So we have this framework of, if you're managing this, if you're managing a project, if you're managing an organization, if you're managing in a ministry, the recommendation is put all of those things, define roles, have people define their own roles. And we have, just to inform, we have created some criteria. We were starting at looking at what are the things, the 20 things that make an implementation guide a good thing, like it has been well authored, has a process, has traceability. We came up with 120 criteria because we see that there's many things that we need to do. So the key word there is, sorry for taking 2 minutes over time, the key word is, it's a technical author done by technical people, but if every technical person does this in the best effort approach and without having a good input and a good process, then we will not have standardized approaches. We'll have just the Fire as a use of technology. And one thing I say a lot, if you only do Fire, if you only know Fire for the technology side of it, then you still don't know a lot of Fire. So thank you for that. I think done with slides. Yeah. Thank you. And next presentation, please.
Cool. Thanks, Jose. So I just wanted to, before bringing up the next lightning talk, so the idea of these is really just to introduce you to some of these concepts, right? Some of this is complex and there's a lot of layers to it. And you'll also hear some of these things like over the course of the next 2.5 days, right? So just being mindful of what is a profile, I've heard that word. Implementation guides are something to do with like packaging up Fire resources and deploying them, okay? Because you're going to hear about these things. So no one's expected to kind of walk away necessarily with like deep knowledge from here, but hopefully it's just giving you a lay of the ecosystem and some of the things to consider.